Good morning to all. My name is Rani, working as assistant professor in Guntur Engineering College. Today I am going to explain about Cmos, AOI and OAI. AOI full form is and or inverter. That means this circuit, the single circuit performs the and invert operation. So the expression I'm taking the inputs as A, B. So and these A, B inputs are 100. Similarly, I'm taking CD inputs are 100. And the result of this 100 AND gates is given to the OR gate to perform the OR operation like A dot P plus C dot T. And the output of this OR gate again given to the inverter to produce the invert operation of and or. That means the final expression for this A over I is A dot P plus C dot P D whole bar. So don't bother about this complementary action bar action. So just think about the product operations and or operations. For performing the product operation, what we have to do? So we need to take the PMOS transistors in parallel and NMOS transistors in series. So here A dot P, so two input and AND gate. That means to perform this two input A dot P operation, I am taking two PMOS transistors Q2 and Q4 in parallel and Q1 and Q3 in series. N1 transistor Q1 Q3 I am taking in series and PMOS transistor Q2 Q4 I am taking in parallel to perform the A dot B operation. I am connecting A input to this Q2 and Q1 and B input to this Q4 and Q3. Again, to perform this C dot D operation, I am taking two more PMOS transistors in parallel and two NMOS transistors in series. So I am connecting this C input for one PMOS transistor and one NMOS transistor Q6 and Q5 and D input to this Q7 and Q8. So to perform C dot T, I am taking Q6, Q8 and Q7, Q5 in series. So to perform the plus operation of A dot P and the C dot D, what we need to, we have to perform the OR operation by connecting the PMOS transistors in series and NMOS transistors in parallel. So that's why I am connecting A dot B input in series with the C dot D. So I am connecting these Q to Q4 PMOS transistors in series with Q6 and Q8 to perform the OR operation. Similarly, I am connecting the Q1, Q3 NMOS transistor in parallel with the Q5 and the Q7 NMOS transistor to perform the OR operation. So like this, we can connect the CMOS AOI logic circuit. So let us see the working of this AOI circuit. If I apply all the inputs are low, so then what happens? All the pull-up networks will be on and all the pull-down networks will be off. So what are the pull-up networks? Q6, Q2, Q4, Q6, Q8. So here Q2 and Q4, Q6 and Q8. So all these pull up networks are on. Pull down networks. What are the pull down networks? Q1, Q3, Q5, Q7. So Q1 off, Q3 off, Q5 off, Q7 off. So this results in output will be pull up to the supply voltage will be. Hence the output becomes high. So hence the output becomes high. So similarly, for any input we can consider the any input. So which transistor is going to on and which transistor is going to off. So by using these and pull-up network connections, how the output will be high or low. So we can mention something in truth table. So I'm taking another input for high, low, low and high. So for high and means A input is high. So for A input high, Q2 off and Q1 on. So what happens? High, low, low, high. Q2, Q1 on, Q2 off. So next B input to low. B input to low means Q4 on and Q3 off. Q4 on, Q3 off. Similarly, for low means C Q6 on and Q5 off. So for D input high means Q8 off and Q7 is on. So by using this connection, so what happens? Output will be high. So like this, we can explain any of the inputs, how the circuit is responding to. The same thing we can mention in the truth table. So how the output will be, we can get. And coming to the R and the inverter. So this circuit is going to perform R and invert operation. So for this, I am giving to A, B inputs and those are R together to produce A plus B and C dot B. C plus D produces. So the same thing is given to the AND gate and output of this AND gate is given to the inverter, which results in A plus B plus dot C plus D whole bar action. So the circuit output is A plus B plus dot C plus D whole bar. So to perform A plus B operation, so I am taking the two PMOS transistors in series and two NMOS transistors in parallel. So I am taking Q2, Q4 in series, Q1, Q3 in parallel. Similarly, to perform the C plus D reaction, so I am taking two PMOS transistors series Q6, Q8 and the NMOS transistors Q5, Q7 in parallel. So to perform A plus B dot is C plus D action, that means product operation. I am connecting this Q2, Q4 in parallel with the Q6, Q8 to perform the dot operation. PMOS transistors must be in parallel connection. So that's why I am connecting Q2, Q4 in parallel with the Q6, Q8. So similarly, Q1, Q3 in parallel in series with the Q5 and the Q7. That means to perform dot operation, NMOS transistor must be in series. That's why Q1, Q3 in series with the Q5 and the Q7. So let us see the working of this OAI inverter. So for the various inputs, if you apply all the inputs are low, these PMOS transistors pull up networks on and pull down networks will be off. The resultant output becomes high. So if both the inputs low, high inputs, then Q1 off, Q2 on, Q3 off, Q4 on, Q5 off, Q6 on, Q7 on, Q8 off, results in high output. If you give high, low input, Q1 off, Q2 on, Q3 off, Q4 on, Q5 on, Q6 off, Q7 off, Q8 on, results in high output. So for similarly, if you apply low input, Q1 on, Q2 off, Q3 on, Q4 off, Q5 off, Q6 on, Q7 off, Q8 on, results in high output. Similarly, if you apply all the inputs high, so then Q1 on, Q2 off, Q3 on, Q4 off, Q5 on, Q6 on, Q7 on, Q8 off, which results in low output. So like this, we can explain the total circuit of OAI by using truth table. I hope you all understood this topic. Thank you. Thank you so much.